Alright, in this first video we're going to talk about what Python is, where to find it. Also going to discuss the Python interpreter briefly and show you some of the basic operators as well as talk about variables. Okay, Python is a general purpose programming language. That just means that, well, hence the general purpose, you can do lots of stuff with it, basic computation, networking, you can make games and do graphics and all kinds of stuff. It works on any major operating system. So if you're on Windows, pretty much, as far as I know, pretty much any form of Linux, and then Mac, and any offshoot of Unix also, you should be able to actually to run Python. Um, there's two major versions right now. There's Python 2 and Python 3. I'm actually going to be showing stuff in Python 2. Specifically, I think I'm in version 2.7, I believe. Um, I don't want to get into tons of details right now about the differences because there's a lot. But if you actually go to python.org, which I'll talk about more in a minute, there's a link that says that's helps you decide Python 2 or Python 3. Basically, the gist of it is Python 3 is the future of the language, but when they created Python 3, they made a lot of adjustments on the language that are not backwards compatible. For example, a big one is how you print to the screen. And since it's not backwards compatible, it breaks a lot of the Python 2 code. So a lot of people, even though Python 3 is the way of the future, most people still use Python 2 just because they don't want to rewrite all their code. So eventually Python 3 will be the big thing, but as of right now, Python 2 is what most people use, and that's what we're going to talk about. You can find it in two places. This is for Windows users. If you're a Linux user, or if you're a Linux user or a Mac user, you probably already have Python installed, and I'll show how to use it. How to check in just a moment. But there's multiple places you can get it, but just two quick places to get Python. You can go to python.org, which is the official website for the language, and there's a download link right there. You can download, whatever version you want. Like I said, if you're going to follow along with me, you're going to want version 2. Another option, you can go to activestate.com/activepython, and you can download the download link and download Python for free through them also. The only reason I'm really showing two is either one of these will work, but if I'm not mistaken, it's been a long time since I've downloaded from Python, so they may have changed it. But this one will set the language up for you, but it doesn't set up your environmental variables and things like that on Windows. So if you don't know how to do that or don't feel like messing with it, you can download it from ActiveState, and when it installs, it'll do everything for you. Um, that's about it on the basics of it, where to find it, and what it's used for. And next we'll go into uh, using the interpreter as well as some basic operators. Alright, now let's get started with messing with the interpreter. I'm actually going to do it directly through the command prompt, which is why if you're on Windows, having your environmental variables and all that stuff set up is kind of important to follow along with me. You can also use a tool called idle, which I'm not as familiar with, but I know that a lot of people will use that to play with the scripts and things like that. But you're free to check that out and learn it. I just prefer the command prompt. It's my opinion that if you're going to program, if you're going to do programming, you're going to eventually have to do a lot of interaction with command prompts or terminals if you're on Linux or a Mac. So you may as well get comfortable with them and learn them, because the sooner you do that, the better off you are. Um, to start the Python interpreter, and by the way, this is also how you can just do a quick check to see if it's installed correctly or already installed if you're on Mac or Linux or Unix systems. You just type the word Python, hit enter, and then if it's installed, you should get something that says Active Python or whoever you installed it through, version number, all that good stuff, and it'll say type help copyright credits and licensing for more information. And then from there, you'll see the three greater than signs. That means you're ready to go. That the interpreter is just waiting for you to type something in. Now, when I say interpreter, Python's actually an interpreted language, which is in contrast to compiled languages. Things like Java and C and C++ and C Sharp and a bunch of other languages are compiled. And what that means is that you can't just run code directly like we're about to into an interpreter. Like with an interpreter, I can just type code in, it'll immediately try to run it. With compiled languages, you'd actually have to write the code, get it error-free, all that kind of stuff, and then you turn it into and run it through a compiler, which makes an executable file, and then in turn, you can run that and test it and play with it. So the interpreted language is kind of neat because you can just play with single lines of code and see how they work. Um, and there's advantages and disadvantages to both styles, but that's just kind of a side note that I thought I'd add in there. But once you start the Python interpreter, you can, well, basically with the interpreter right now, we're just going to use it as a calculator, just so I can show you the different operators, what they look like, and how they work. And I'm also going to just kind of talk about three basic types. Um, First type I'll go ahead and show you is called the float, which is a floating point number, is what that means, which is basically a decimal number like, 4.1 or negative 2.7, something like that. And I'll show you the basic math operators with those first. I'll start with 4.1, and we'll say 4.1 plus, use a plus symbol just like you would in math class. Say 1.2, gives you 5.3, it's what you'd expect. Subtraction is the same idea. You use the minus sign just like in math class. And then here, I'm going to explain this too with floating point numbers, and we'll get into more detail with this later on when it becomes when it can become an issue and cause you problems in your code. You'd expect to see 2.9 here if you just did this on a piece of paper in math, but you see it says 2.89999995. Well, just to kind of make a quick explanation of it, computers do everything in binary or base 2, so everything in computers boil down to zeros and ones. But typically in math class, as humans, we deal with a base 10 system. We deal with 0 through 9. So sometimes when you do this math and you translate from base 10 to base 2 and back and forth, it causes rounding issues. So even though we know this should actually be 2.9, the rounding issue causes this weird, not weird, it's expected, but it causes this kind of weird rounding that you'd see here. We're not going to worry about that right now. Later on, it can become issues, and you have to be kind of aware of it. But hopefully, I'll remember that and have an example that will show that. But anyway, next we'll do multiplication. We use the asterisk symbol for multiplication in Python. That's pretty typical for most programming languages. It's pretty standard fare. It multiplies just like you'd expect, minus the weird rounding thing. And then division, we use forward slash. Once again, it divides, and you're going to see a lot of this kind of weird rounding, but it's with the floating point numbers, but it's something we'll take care of later. But the point being on this one, I started with the floating point numbers just because the four basic operators work exactly like you would expect if you sat down in math class and started doing something. They work just like you would think. But that's the floating point number. Like I said, it's a decimal point number, and that can be positive or negative, and this would actually count as a float too, by the way. Even though there's no value after the decimal, it's just a zero, it would still be considered a floating point. So that's something to kind of note. Next, we'll talk about integers. All an integer is, you may have heard the term, may have not have heard the term. An integer is just a whole number. It can be positive or negative, but it's a whole number. So, -4, -3, -2, 0, 1, 2, 3, 4, in both directions, infinity and negative infinity. As long as they're whole numbers, that's an integer. For the most part, they're going to work like you'd expect. For the most part, multiplication, or not multiplication, addition, subtraction, and multiplication with whole numbers or integers work exactly like you'd expect. The difference that comes in is when you do division. Say that's the 5 divided by 2. Well, you would expect it to be 2.5, but you'll notice it actually says 2. Well, the reason why, you'll have to kind of throw back to I guess second, third, fourth grade, whenever you do it, but long division. When you have a whole number on either side and an integer on either side, then division is actually done using long division. The whole 2 goes into 5 two times, and there's a remainder of 1. So when you have the whole number and you do division, you get the quotient value of it. And then if you can use a different operator, which is called modulus, which is just a fancy math term for remainder, and we note it by using the percentile sign. That will give you, see, the answer of 1. That will give you the remainder of this division. So 5 or 2 divided by 5, 2 goes in 2 times with a remainder of 1. So that one's a little bit weird. I know a lot of people are puzzled when they first see this idea of why are we doing this weird long division thing that we haven't done since third grade. Well, there's reasons behind it, and it's actually can be very useful. There's a lot of times when the remainder on a number can help you solve problems really easily in computers with when you're doing programming with the computer. Quick example I can give is if you're trying to figure out if you know a number is even or odd, you can do the remainder of 2, and if it's an even number, then there's not going to be a remainder because 2 will divide any even number. And if there is a remainder, you'll see, or then you'll know it's an odd number. We'll show examples like that to make it less confusing, but it's just kind of you have to get in the mindset that computers are extremely, extremely stupid. They do exactly what you tell them to, and they don't have the ability to think on their own. So sometimes you have to break stuff down in what would be weird ways, but you get used to kind of bending your mind to thinking that way. Thinking of how to solve problems in the term of mathematics, which I guess maybe I should have said at the beginning. If you don't like math, you're probably not gonna like programming. Um, just putting that out there for you. All right, third type we're going to talk about is called a string. Now, and I saved that for last because it's the most complicated one. String is a series of one or more symbols, characters, or symbols, letters, or numbers. You're just generic characters type thing, and they're denoted by having some value, like I say hello, and then put it around quotes. And when you put it in quotes, that lets Python know you're talking about this. This is a literal string value. I use double quotes. You can also use single quotes, either one. If they just have to match on both sides. Like for example, if I do one of each, it's going to complain about it because it doesn't. It says EOL while scanning string literal. So basically, it was looking for this other double quote. That's what I started with, and it didn't see it. But then if I do this, it's fine with it, and it just echoes out back to the screen when I printed. But anyway, the reason I say this one's a little bit more complicated and confuses people is if it's in string format, then this looks like a number. It looks like 1, 2, 3. But this, in a string format, 123 with the quotes around it is a string. This, or this is an integer, and that's a float. My point being, the number 1, 2, 3 is not the same thing as this. It's a string. It's a string version of it. The best quick analogy I can think of would be, say if you took 1, 2, 3 and put it in you're on your computer, you open up the calculator, and you put 1, 2, 3 in the calculator. Well, from there you can manipulate that value. You can multiply it, divide it by some number, add or subtract or what have you, and get new values. Well, that's what this is like, or that's like. The string 1, 2, 3 would be more like if you were sending an email and you wrote 1, 2, 3 inside the email. Well, yeah, it still looks like a number, but you can't actually do anything mathematical with it because in this email format, you can see it and read it, and you could add stuff to it. You could add stuff to it, as in make the string longer or type more numbers behind it, but you can't actually do anything mathematically with it. That's kind of the basic difference. String's the one that usually trips people up the most, but you'll play with it a little bit and you'll get used to it. The only real basic operator that I think might be useful right now for you guys to see with strings is string concatenation, and that is denoted by a plus sign with the strings. What that does is it takes the string on the left side and the string on the right side and pastes them together, copies and pastes them into one string, like and then exactly verbatim how they are. Like when I run this, you'll see that this whole word will get jammed together because I don't have any spaces in there. It'll say hello Bob, but it's all one word. So you can see that it literally takes this and takes this, shoves it together exactly like they are, and comes out with a new string that contains both. So if I wanted to have a space in there that was readable, I'd have to put it on one of the sides. That's basically it on that one. I guess the other one I could show you, which you probably won't use much, but if you see it when you're playing around, you'll realize that you're dealing with a string. And I'll do it with number, just so you can see. Say I had the string, string 12, and I wanted to multiply it by 3. And this will also show you the fact that the strings and integers or strings and numbers are considered different things. Well, 12 times 3 is 36. So if you didn't realize this was a string, you'd expect the answer 36. But you see that you get 1, 2, 1, 2, 1, 2. I forget what the name of this operator is for strings, but basically, if you have a string and you multiply it by a number, it takes that string and copies it however many times you tell it to and pastes it together in one big string. So if you're playing around with with multiplication between two things that you think are numbers, and you start seeing some kind of weird stuff like this, you've probably got a string on one side or the other. But that's it for the basic operators. I know I kind of went quickly on this, but um, you know, kind of assuming that you guys that are watching this are gonna play around with it. You can send me questions, and I'll gladly try to answer them as much as I can with time permitting and all that kind of stuff. But with programming, unless you're some kind of super genius, you're not gonna just be able to watch a 5 or 10 minute video and be a guru on some particular part of programming. So you're gonna have to look at documentation, play around with stuff, and that's gonna be the best way to learn. The good news is with the basic stuff like this, like multiplication, division, a lot of these other videos that I'm going to do in Python with if statements and while loops and things like that I'm going to talk about in future videos. All that stuff is pretty standard fare for any programming language. So the good news is once you master it once, then you go to another language, then the ideas are the same. It's just maybe a slightly different syntax you'll have to get used to. All right, this last section we'll talk about variables. I'm just going to kind of try to go quickly, just give an idea what they are, maybe show a quick example. Because when you're dealing with the interpreter, variables usually aren't as useful when you're just dealing with the interpreter directly. So like in the next video and the videos after that, when we're actually writing the actual Python scripts, writing the larger amounts of code to a file and running it all at once, then variables become very useful, and you'll see plenty of examples then. Basically, all a variable is it's a named spot in memory. You just arbitrarily name it whatever you want, and then you can save data in there. Like the way that memory works right now, if you just try to access it directly, like if you're going to access a part of the RAM on your computer, you could just type out the memory address like 0x blah 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 blah, some hexadecimal series of numbers after it. But that's kind of a pain in the butt because especially if you have several of them, the numbers are going to start to blur together, and it's going to be kind of hard to remember what has what in it, and it just kind of looks ugly. So by having named variables that you arbitrarily name, it's just a programmer's convenience. It lets you associate a name with some value instead of some string of some like long thing of numbers. But basically the syntax is going to be this. You have to have one or more letters, numbers, or underscores is the syntax for a variable. However, the exception to that little caveat is you cannot start a variable with a letter or with a number, excuse me. So I could say I could have a variable that I call you know b1, and that's totally fine. But I couldn't have a variable called 1b because it starts with it. I could also do something like this, and I could just different values. Um, so let's just start off with one called, we'll just call it number, and by naming it number, we're kind of implying that we're going to have a number in there. However, that's kind of the programmer's duty to keep track of that. If you name a variable with the kind of hint towards some value or some certain thing, it's still your responsibility to make sure that's what goes in there, because the interpreter won't check that for you. If you want to get technical, it never actually sees the word number. It just gets translated into the memory address, so it never even sees it. But anyway, you can say number equals 4. This equal sign in this case is the assignment operator, which says take whatever's to the right of me and shove it inside of this name spot in memory. Hit enter, and it appears like nothing happened. It just goes to the next line. But if you type number, which if you just type the name of the variable directly in the interpreter, it's going to go find that spot in memory and then regurgitate back what's in there. You'll see there's a 4. But then I can turn around if I wanted to, and I can turn around and say number equals 4.8. It's going to accept that or spit 4.8 out. Or you can put in a string and say hello, and then spit that out once again. The reason we can do that in Python is because variables are dynamically or loosely typed. What that basically means is, as you can tell from what I just did, you don't have to tell Python what type of data you're going to put in there. It just figures it out, on its own by looking at what you entered, and then it'll adjust back and forth and let you switch, which is pretty cool. A lot of languages won't let you do that. You like a lot of languages, for example, going to this first line where I put an integer in there, I would have actually had to say something like int number equals equals 4. You know, to say, hey, I'm going to have a variable called number. It's going to hold an integer, and then I'm going to put a 4 in there. And then with languages like that, which are strongly typed, once you've actually entered that, you know, you've committed to a certain data type with a variable, you can't switch back and forth like we did here, where we switched from 3 different types. But that's the basic idea with variables. I mean, you can manipulate them or use them for manipulation. Like, well, actually, let me change this back to something. Okay, say number equals 4 again. So as you can see, it has the value 4. So I could actually say number. Man, I can't type. I could say number times 4, and it gets 16 returned because the value 4 is inside number right now. So 4 times 4 equals 16. That's a little bit of playing around with variables. You'll see a lot more examples and uses of them, and well, starting with the very next video that I do. So I'm not going to get into too much more detail on that right now. Oh, and I almost forgot to mention, if you're dealing with the interpreter directly like this in the command prompt, when you're done, you can also just exit the window, but if for some reason you need to actually stay in the terminal or you want to restart the interpreter, you can just type exit, open parentheses, close parentheses, and that kills the interpreter.